Morning. Morning. Hi. All right. Welcome back. Today we'll continue on what we were doing. Today we're going to go over surface area, pyramids, and cones. Last week we talked about surface area of pyramids and prism and cylinders, right? So it's very similar in the sense that we are still looking at each faces, basically. So if you can see, this is a pyramid, right? So you have two parts. You have to find the base area, which is what we have been looking for, right? The base area, polygon, that kind of thing. You have to find the apothem and all that stuff. The faces, however, if you have the right pyramid, then when you cut it open, each of them will be isosceles triangles, right? 1, 2, 3, 4, right? And because, look, this is a triangle, right? Each one of them will then be half base times height, right? 1/2 base times height, 1/2 base times height, 1/2 base times height, 1/2 base times height. So in total, the whole thing should be 1/2 base S times height L, but you have 4 of them, right? Like that. And since perimeter is 4 times S, you can rearrange it. So 4 times S is going to be perimeter, right? So it'll be 1/2 perimeter times the height. Now this height is different from the height of the pyramid. Why is that? Type it in the comments. Why is this L different from the actual height of the pyramid? What's the difference? All right, I'm going to write down an objective while you do that. Question is, once again, how come this L is not the same thing as the height of the pyramid? Okay? Alright, type in the comments, why is this L not the height of this? Or maybe it is. I don't know, why should it be or not? Okay. Are we clear on what I'm asking? Do you understand what I'm asking? Exactly. So this L is basically, if you look at the pyramid, is slanted, right? If you look at this from the top all along the surface, right? Oops. Along the surface here. But the actual height is down here, right? So slant height is different from the actual height. Okay? And when we're doing the surface area, we're interested in the area of the surface. So when we use the height, we'll use the surface height, which is the slant height. Does that make sense? All right. Now, here we go. So now let's calculate. All right. So we know the lateral area, which is all the lateral area together, is 1/2 perimeter times slant height. Okay. It's 1/2 perimeter times slant height. Okay. Slant height. Okay. We good with this? Alright, so let's practice with one. So when we were doing it, it's slant height. The whole surface area will be the same as lateral height plus the base, right? So we're gonna do two parts always. It's going to be the lateral, which is one half perimeter, okay? Now, perimeter times slant height, right? The perimeter here is, this is just a hexagon, right? 1, 2, 3, 4, 5, 6, right? So 10 of them, so what's the perimeter? That's going to be 60, right? Perimeter is 60. And then, lateral height is 16, or 80. Just square. That's just the lateral surface, which is this. Base is kind of your favorite problem, right? We've been doing this. Hexagon. Times. Can you find this area real quick? We'll find this. Is it lagging? It's lagging, huh? It's lagging. Not good. Hopefully it corrects itself soon. YouTube hasn't been smooth the past few days on streaming that I noticed. So bear with me if you can hear me. Basically what I want to do, once we find this, right, this is 480 inches square by the formula. Okay, I want you to take 2 minutes to find the base area, which is a regular hexagon with length 10, edge length 10. Find that base area, and we'll verify the answer once you're done. All right, 2 minutes to verify what the area of this regular hexagon is. Okay. So calculate this. Do you have an answer? Type the answer in once you're done with the B, base area. Let's see if we get the same. Thomas got 259.8. I think you're correct. It turns out to be 259.81, right? Something like that. Right. Inches square, and then you just add them up. Okay, once you add them up, you will get what, 739. Okay, so that's your surface area. Okay, surface area is equal to that. Add them up, right? If you don't remember how to do this, let me remind you how. You have to cut into 6 triangles, right? And you find an apothem. To find the apothem, you have to first, this is 60, and then cut in half is 30. So use tangent 30 equals to, this is 5, right? So 5 over a. Okay, and then you solve for apothem. Once you solve for apothem, you can do 1/2 base times height, and then u times by 6. Okay. If you're still confused by this, go back to look at the previous chapter, I think. Previous chapter? I think it's this chapter, right? 11.4 maybe? I don't remember. Anyway, so we've done this for many times, okay? All right, you try. Try this. While you try this, okay? So once again, you want to find the lateral area. Right? It's 1/2 perimeter times sled height. And then you want to find the base area. Right? This is also a regular pyramid. Okay, regular pyramid means that the bottom part base is a regular polygon. Okay? So you gotta find the base area as well. While you do that, let me take attendance. So if you're here, please type here so I can take attendance real quick. All right, we haven't answered yet. So first of all, we got the lateral height. Lateral perimeter is 16 times 4, right? So that's 64. Okay, 16 each side, right? So times 4, 64. Slant height is 17. Okay, so that's going to be what? 32 times 17. which is 544 inches square, and the base is going to be 16 square, right? 16 times 16, which is going to be 256 together. Right, add them up. So surface area is going to be, I think it's 800 inches square. Very nice. How are we doing? It is acceptable. Pretty good. Okay. So, first page, can you give me a number 1 to 10, how comfortable you are with this calculation? 1 to 10. Okay, so basically this, for those who are 6 and 7, let me re-explain it again. Basically, you want to find the surface area, right? So surface of the pyramid includes the base and the side triangles, right? The side triangles is basically what we call lateral area. Lateral areas are a bunch of triangles added together. So what you could do, instead of doing the formula, is that you can actually calculate individual triangles. So you calculate one triangle area, right? So triangle area for this one, for example, will be 16 times 17 divided by 2, right? Because 17 is the actual triangle height, right? So it's slanted for the pyramid, right? So the triangle is slanted, so the height of the triangle is slanted. So when you do the triangle area, it's going to be 16 times 17 divided by 2, right? Once you get one triangle, you can multiply by 4, so you get all 4. The reason why this formula works is because when you multiply by 4, the perimeter can be obtained by rearranging it. So like your 4 times the triangle becomes 4 times 1/2 base times height, right? 4 times the base is going to be perimeter. Alright, that's why there's a formula. But if you don't feel comfortable with the formula, you can still go face by face and add them all up. That's fine too. Okay, that's also a possibility. Now, the base just depends on what kind of base you have. You just calculate the base area. If it's a regular hexagon, then you use hexagon. If it's a square, then you use square. Okay, that's basically it. Okay. All right. So now let's move on to the cone. The cone is the same thing as the pyramid, because cone is a circular pyramid, right? So remember when you had here, right? Your surface area for the pyramid was 1/2 perimeter times slanted height, right? And this part was the base, or whatever base is. Now let's look at each part, okay? Well, for cone, what is the perimeter? Isn't that the circumference? What is circumference? Isn't it 2 pi r? And then times slanted height, right? Plus, what's the base? Base is a circle, so pi r squared, right? So you see how like 2 and 2 cancel. So then that's how you just get this formula here. Okay, so it's the exact same formula, or same way of calculation. It's not even, it's barely even the formula, right? It's just like putting things together. So plus the base area. It's just that now they're more specific for circles. Okay? That's the idea. Are we okay with how we got this calculation? Okay. So let's flip. So now let's use them to calculate. So this. So lateral area and surface area, right? So lateral area is going to be 1/2 circumference times length will be pi RL now, right? Pi RL, which is going to be pi radius is 8 times slanted height. Oh, okay. There's no L. Can I find L first? What will L be here? If you look at this is a right triangle, right? If it's a right triangle, you can use the Pythagorean theorem to find that L is 17. Well, how do I know it's 17? Well, just do a squared plus b squared equals c squared. Okay? You can find L squared. And it turns out to be 17. Now, if you are confused about this one, you can go back to the previous page. The previous page also have this set up on this problem. Okay, this is the same triangle on this problem. Okay. All right. All right. So, that being said, now the base, right? Well, base is easy because it's just pi r squared, which is pi times 8 squared, which is going to be, oh, I haven't calculated this one yet. We can leave it in pi, so 64 pi here, and this one is 17 times 8, right? Which is what? Oops. 136. So then you add them up, right? So surface area will be 200 pi inches squared. Okay. You try one? So once again, we will do two parts. Right. IRL. Right? Radius is 8, right? What is your slant height? What would this part be? Ten. Right? Okay. So then you just times 10, and you get 80 pi here, right? And the bottom part, same thing. You get 64 again, right? 8 squared. Okay. Then you add them up, so it would be 80 plus 64, so 144. How comfortable are we? 1 to 10. Oh, I get it. Give me 1 to 10. How good are we with this? Now we take out the calculate base area out of the equation, right? I mean, like this part feels easier because it's easier to find the area of the circle in general, right? Why is it 10? So the right triangle here, right? Right triangle, you want to find L, right? So that's the hypotenuse. So you just 8 squared plus 6 squared equals L squared. And this is 100 equals L squared, so L is 10. Oh, it's fine. Aditya, I already got you. Does this make sense, John? You get that 10 because this is a right triangle. Okay? Alright. So, last part I want to talk about before we do some challenge is, well, not even challenge. It says base edge length is 10, slant height of the regular hexagon are both divided by 5. So this divided by 5, this divided by 5. Describe the effect on surface area. So we're not even going to calculate it, okay? I'm going to kind of tell you what happens, okay? Look at this. When this is divided by 5, then this will be what? 3, right? Yeah? This divided by 5, this will be what? 2, right? I mean, we can calculate it, but what happened? We scaled down a two-dimensional object, right? We're doing a surface area, right? Surface area is two-dimensional. Right, two-dimensional. Two-dimensional, meaning that if I divide a two-dimensional object by 5 on each dimension, how would the effect look like? This is length times length, right? That's the surface area. Both of the lengths are divided by 5, so the whole surface will then be divided by 5 twice. Okay? Twice. That means, right, this becomes 3 instead of 15, this becomes 2. So when you multiply them together, it will be divided by 25, or 5 squared. Okay? Divided by 5 twice. If you don't believe me, you go ahead and calculate this whole thing, and you'll see. Yeah. So this kind of problem, you don't even have to really calculate it. Okay, so SA is divided by 25. Okay, because you divide by 5 here, you divide by 5 here. Okay. This is the same thing as the similar triangle. What happens if you divide both the base and height by 2 or scale factor of 3? What happens to the area? Okay, it's the same problem. Similarly, if they both multiply by 2/3, what would you think it would happen? Type in the comments. What do you think it would happen? What will happen to the surface area if I multiply both slant height and edge length by 2/3? What will happen? It would get smaller, but by how much? So you multiply each dimension by 2/3, right? Once is base, once is height. So you multiply by 2/3, and then you multiply by 2/3 again. Then the whole thing would be 4 nines, right? 2 square over 3 square. So the surface area would be multiplied by, will be 4 ninths of the original. Okay? 4 ninths the original. That's the idea. Okay, that's the idea. Alright. It says challenge, but it's not really a challenge. If you look at it, it's just a composite figure again. How would I calculate the surface area of this? Well, first of all, remind you that surface area is only on the surface. So this part doesn't count. Okay, this part doesn't count. Remember, we talked about this last week? So all we're calculating is 2 lateral heights, right? Lateral height here, lateral height here. Lateral area here, lateral area here. So it's basically 2 times the lateral area, right, of a cone. So remember, 2 times pi RL. Pi RL. They already tell you what R is. They tell you what L is, and you just calculate it. 24 pi feet square. Okay. Once again, this is a 2-dimensional object. Okay, so feet square. Okay. As a whole, this this section, how do we feel? 1 to 10. Give me a number so I have a good feeling or a bad feeling about this. So your homework. 11.7. This is on big ideas already. This is due Sunday. I think it's the 31st, right? This Sunday is 31st. Yeah. Okay. So that's your homework. Make sure you do them, okay? Keep up with your homework. Okay. Anything else before we call it? Next week is going to be our last section on chapter 11, which is going to be spheres. And after that, I think we'll have an assessment on finals week. I think, yeah. You're gonna do it on in class, I think. Okay, and that's all. We're good? Any questions? Any question? Like in general? No? Alright. If you have questions, hit me up on Remind, hit me on our email. Yeah. You can ask any question. Finals is final is chapters. We're probably just gonna have a semi-final. Semi-final. You get that? It's kind of be the last test. Oh, by the way, your grades are updated. As you can tell, the tests kind of just act like a participation point, kind of. Right? If you did it, you probably get full credit. It's just that yeah. So the finals probably going to be similar, but it's not like, yeah. pretty much take the whole final category out of the discussion, basically, to ensure that people can pass the class if they do the work. Okay. We will probably not have a separate Chapter 11 test. Okay, so we don't have time. Does that make sense? I mean, if you really want to practice, I can set one up, but I don't see the point, really. Any other questions? The final is the class on the week of June 8th. I think it's the same. I think I heard right. We have regular scheduling that day. We don't have like an official final week like how we usually do. So it's just gonna be a regular week. Okay. Your books, I don't handle that. I think your books will come back when you return to school. Okay. We're not going to do return books just yet. Okay. Any other questions? If not, I shall see you Arvin, did you miss the whole thing last week where I talked about this? So there's staffing issues. Basically, there are too many students in Monte Vista. Too many teachers in Monte Vista. So I've been transferred to Lynbrook for next year. I could return afterwards. Next week's the last week? Wait a second. Maybe I'm wrong. Maybe we don't even have a final. Let me see. Wait, today? Hold on. Maybe we won't have a final after all, if that's the case. Next week's the last week? Really? You see how, like, you know, when I don't read the emails. Is there a loop mail that says that? I forgot. Man, you guys need to tell me these things. Wait. Oh, grades are even due on June 9th. We don't even have finals week anymore. Good job, guys. Wow. Well, I still have to do 11.8, so that, you know, it'll be short though. Maybe we can talk about things afterwards. And maybe you can see my face. Where is that mail? Message from principal? What does that say? I don't see it. Do you guys see it? Can someone send me a link to wherever that thing is? Whatever it says that next week is the last week. Oh yeah, I saw. The last week of classes for grades 9 to 11 will be week of June 1st. Congratulations! I guess we won't have a final after all. But I mean, it doesn't really matter to you guys. You guys been great. You guys do your homework. You guys do, you guys are the only class. Okay, the only class I don't really have to worry about doing homework. All right, like you just always do your homework. That's great. Like, can't say that about other classes. Way to keep up. All right, way to keep up. Okay, so that's it then. Next week I'll see you for one last time before yeah. Who knows if we have the if we're fortunate enough to see each other again afterwards, then maybe that will happen too. But for now, next week could be the last time. All right. I'll see you guys then. All right. Catch you next week. Oh, thank you. Thank you. Goodbye.